All right, so on the last page, we have examples 11, 12, and 13. So we're going to do as many as we can to get this out the way today. And then tomorrow, we'll just take the quiz. All right, so Sarah posts a joke on her social network page. 4 of her friends repost. 4 of each of their friends repost the joke, and so on. How many people will repost on the 9th round, or posted on the 9th round? All right, so we could do 9 rounds all the way to A9. But here, so we can just jump straight to A9 using our explicit formula. So A1 is the first round. So in the first round, 4 of her friends repost. In the second round, 4 of their friends reposted each. So that's 16. So if we use our formula, A9 equals A1 times r to the n minus 1. So we're looking for A9. A1 is 4 times r is your ratio, which in this case is times 4. So here's r. And n minus 1, n is 9, so we do 9 minus 1. Again, big number in the calculator. So just type in 4 times 4 to the 8th power. 4 to the 8th, if we look at our chart, is that 4,096. And then we multiply that by 4 again. So this times 8 would give us, typing it in the calculator, 262,144 people. 4 to the 8th power. All right, so here, actually our chart doesn't even go that high. None of those have 8th powers. So this is the total number of people. Again, you could have just multiplied all the way till you get to the 9th round. That is one way to do it. But just jumping straight there using the explicit formula that we just learned. All right, the last two, or the example number 12, is writing an equation. So again, I find it helpful anytime it wants an equation for the nth term. This is an explicit formula. So we'll go ahead and write the formula down. A sub n equals a sub 1 times r to the n minus 1. So here we're making an equation for a sub n. A1 is 0.5, because that's the first term in our sequence. And we multiply that times r. Well, we got to figure out what r is. So what are we consecutively multiplying by? Multiplying by 4. So this is our r. And then we leave the exponent as n minus 1 because we don't have a value there. So for this one, that's all we really have to do. No, you cannot take half of 4. Order of operations say you got to do exponents before you can multiply by the a value. So here, don't try to simplify it because you can't. That is the equation we want for that one. All right, and b, same thing. We're trying to make this equation right here for a to the n. But if you notice what we have this time, for a to the n, we don't know what a1 is. We start at a4. So there's a couple of ways you can do this like we did yesterday. We know r is the 6, because it tells us what the common ratio is. And so we need a1 here and n minus 1 there. All right, so again, 2 ways you can find a1. You start at a4, and we're trying to go backwards to a1. So it gives us that a4 is 5. So if we want to go backwards, we would consecutively divide by 6 to go backwards. Now, when we divide by 6, these are not nice numbers. So I'm just going to leave them as fractions. So 5 divided by 6 is just 5/6 divided by 6 again is 5/36. And divided by 6 again is 5/2/16. So this is the number we need right here for A1. And really, we're done once we plug in that A1. But I want to show you the other way to do it, because you're not always going to be able to just work backwards. I mean, you will always be able to, but then sometimes it might take a lot of steps. So the other way to do it is to take the number that they give you, the A value that they give you. So they give us A4. So A4 equals, and we want to solve for A1. So times 6. And for the A4, N is 4 here. And we're going to do -1. So I know A4 is 5. So I'm going to substitute the 5 in there. So 5 equals A1 times 6 to the third power. And then we just evaluate and divide. So 6 to the third. 5 equals A1 times 6 to the third is 216. So if we divide both sides by 216, we get that A1 is 5/216. So again, that's the way to solve it algebraically, but you could do this. Don't forget your equation part. So the equation is A sub n equals, we found the A value, the A1 to be 5/16, so 2/16 times R is 6, and we leave it as n-1 as our equation. So that's the final answer there. But again, here we actually had to solve for it before we were able to get that equation for A1. So we did a similar one like this yesterday, working backwards to get the missing number, or to get the first number, or solving it to find the missing value. We're actually going to have to do this for example 13. So example 13 is the one that takes the most work when it doesn't give us anything in the equation. So here it gives us 2 terms in the sequence, but it doesn't give us R, or it doesn't give us A1. So we're trying to make an equation for this. So again, if you want to set it up, let me zoom out a little bit because we're going to need that space. So A1, A2, A3, A4, A5, A6. So they give us the third number in the sequence is -48. And then they give us that the sixth number in the sequence is 3072. We need the R value that takes us there, and then we need the first number for the formula. So there's a couple of things we can do. No, you cannot just subtract this and this and divide it by 2. That's a linear sequence, not a geometric sequence, or it's an arithmetic sequence, not a geometric. All right, so I have 4 steps over here that I'm going to write, and these are what we're going to follow over here. So step 1, we want to solve for A1, and usually we do this for the smaller term, the first term. So in this case, we're going to do it for this one. Not the smaller numerical value, the smaller number in the sequence. So this is the number that comes first. All right, so we're going to set up our equation. So I'm going to go ahead and just write the equation. A(n) equals A1 times R to the n-1. So for step 1, A(n) is the third one that we're looking at. We don't know what A1 is. R, we don't know what R is, but we know the exponent is 3 minus 1. So A3 is -48. A1 stays, and R 3 minus 1 stays. Actually, I'm going to